All right, everybody, welcome to MS-DOSX Lecture 15. Today we're going to go into detail about table views, table controllers, and that sort of thing. Okay, so a table view it's a vertical table, single column. You can have a whole bunch of rows. You can have a whole bunch of sections. They're very common. Can anybody here think of an app that doesn't have them somewhere?
Yeah, pretty much every iOS app you see has a table view or something that looks like a table view in it somewhere.
They're basically universal. Okay, so there are two styles of table views. There's the kind that you see in settings where they're grouped. You have a shaded background. And there's the kind you see in the iPod app where there's just a great big list. This is actually not the best comparison because there's no groups on the right side, but anyway. So these are the components of a table table view. There's a header, which is a single thing independent of everything else in the table. There's footer. These are sections. The sections can have headers and footers themselves. And the grouped table has its own analogs, except the spacing is a little different, and the headers have no shaded backgrounds on them. Okay, so the naive solution to sticking stuff in a table view, you might think, well, okay, I've got a bunch of data, I want to display it on the screen, I'll stick it in an array. So that won't work very well because an array, you load the entire thing into memory, and you can have very, very, very big tables. So if you were to do this, you'd have to load everything from your table into memory before you could display anything. If you, for whatever reason, happen to have more content in your table than your device can store in memory, you're kind of out of luck. So instead, there's a table view data source object that provides data on the fly as you need for whatever happens to be displaying in the table. You only load stuff when you need to display it. It's a lot more efficient. And these are the most important functions on the table view data source object. You can specify how many sections you want in a table view. The settings app example had a bunch of sections. The music app example had no sections. And then you're required to specify how many rows are in a given section. For example, over here, if you wanted to have only one section, you might say NS integer table view, number of rows in section. Section would always be 0 if you just have a 1. And then always return, for example, 25 or whatever number you'd like, or you can compute it on the fly. Similarly, you have to return a UI table view cell object. We'll go into detail about that in a little bit for any given row at index path. So you might be wondering, okay, what's an index path? It's a system, think tree structure except in arrays. And here, this index path is 1.2.0. It's a useful data structure that's also used for tables because you can have section.cell number or whatever. So the data structure is kind of used for the table view system using this UI table view category on the NS index path object. So you can take an index path object and query it. You can ask it, okay, well, what row do you represent? What section do you represent? So it's useful for that. Another important thing with tables is, okay, this phone can maybe display 8 table cells if they're about average size. And if I have a 2,000 row table, it's going to be pretty icky if I'm going to have to create 2,000 table cells and keep them either lying around in memory or manually manage them. So what you do is you only keep 8 or 9 table view cells actually in existence. When you scroll up a little bit, you change the content of the table view cell that just disappeared and then reassign it to the table view cell that's about to appear, and so on and so forth. So what you do here when you're getting the cell for row at index path, which is the populate the table method, you can call a method DQ reusable cell with identifier. You don't need to worry about identifiers right this minute, but that's useful if you have complicated tables. And this just asks the table view, okay, give me a table view cell that I can do something to. Give me a table view cell that's not actively in use for something. And then if you don't get one, such as, for example, if you're loading an empty table and you just haven't loaded any table view cells yet, then you can actually create one. This is a fairly standard view initialization. You allocate, you initialize with a frame, and you again have this reuse identifier. You auto-release it because its memory management is handled, and here you can set its text to, for example, an array that keeps track of text in the table. So here we actually are using an array for the backing store, but for something more complicated, you could use whatever data structure you'd like. For example, if you have something really complicated, you might want to use core data, which we'll mention briefly at the end of the lecture.
It's worth noting that typically you don't actually have to worry about writing the code for handling cell reuse. Typically, you'll create your own table view controller subclass, and we'll talk about that in a little bit. And the skeleton code that's provided when you create a new table view controller will already provide a skeleton for that method that already does all of the dequeuing and reusing cells. So usually you don't ever have to worry about that.
Yep. So here are some more useful methods on the table view data source. As usual, if you want to get a complete list of these, look in the documentation, or in Xcode, open the file UI table view source, data source rather, .h, and you can get a list of them all. So you can set up sections with headers if you so desire. You can also use table view cells for, rather than something like the music app where you're scrolling up and down, tapping on things, and so on and so forth, for stuff that you can actually edit, such as, for example, if you have a task manager application, you might want to have a table view cell for every item in your to-do list. So you would want to indicate whether you can edit or move the table view cells in those in your app. Or you might want to set what kind of editing style the table view cell, or all of them, has. So all of these you can, for example, this table view can edit row at index path. You could just return yes, and then all of your cells will be editable. So there's the table view data source, and there's the table view delegate. And usually they're the same object just to keep things manageable. And here, instead of providing data, you decide how the table view is going to behave. So there are delegate methods. Table view will display cell for row at index path, so do something if a cell is about to be displayed. Table view will select row at index path and did select row at index path. So for example, if somebody is about to select a row, you can prepare to do something, or you can do something after it's been selected, such as pushing the next view controller on if you're using a navigation view controller. So you might have seen table view apps on iOS where they just look glitchy. Like you tap something and it doesn't get deselected, or you're scrolling around and there's a selected cell, and that just looks weird. You shouldn't use selection to give state of a cell. You could, if you want to do that, you can modify the cell object itself, like change the text color or something like that. Just cell selection can be janky, and if you try to use cell selection to indicate something, the user is probably going to think, well, this app looks weird, because that's just not how things work. If you have the split view thing, like for example the settings app from the split view controller, or mail here, then you can have selection make sense there, because you have two independent tables. But as a general rule, just don't do it. What you usually do is trigger some sort of an event when you select a cell, and sometimes you might not want to. Let's see. Nothing particularly worth noting there. You can conditionally say no. Anyway, so the UI table view controller will automatically create the table view object for you. It will set up the delegate, the data source, and it'll handle a few behaviors that you don't want to need to worry about. For example, there's a reload data method that you want to call on a table view when its data source changes. So that needs to get called when the table view first loads. The table view cells, by default, you have an image view property, a text view property. There's a subtitle view property. Isn't there? Subtext?
Yeah, and there is a third one for like a subtitle text.
Yeah. So you get a few out of the box in that method earlier, where you're dequeuing a cell if it's available or creating one if it isn't. You can programmatically access that cell and set its image or text to whatever you'd like. Most of the time, you're going to want to do something, or rather, if you're doing an app that's particularly complicated or fancy, you're going to want something that looks different from, say, the default music app. So you'll want to manage subviews manually. But if you're doing something quick and dirty or simple, then this is your friend. There's also this indicator on the right-hand side. You should be familiar with all of these. You've got the, this is something that you'd see commonly in navigation controllers. You tap this row, and it zooms in effectively. This check mark, you tap the row to select something, that sort of thing. Okay, so if you opt to not use the predefined, okay, I have a text field, or rather a UI label, and I have an image, and you do things manually, you'll be returning a UI table view cell object, but the table view will just assume they're all the same height. So you may also need to override the table view height for row at index path method. So for example, this text auto-sizing is nicer on iOS than it is on macOS. You have text of however long you want it to be. Suppose you've got, let's see, there was an MSDOSX project a couple of years ago where you were supposed to write an iPhone app that was a client for fmylife.com. And you were supposed to provide a table view that had nothing but text in each row, but it was supposed to display the entirety of an entry from that website. So you could do this. You query text from the API, you pick a font, which could just be UI font system font of size, for example, 9 points or 12 points, and then you can ask the string to size itself given a maximum size, add some padding, and then you're done. So for example, if you have a single line, this will return a minimal value. If you have the entirety of the United States Constitution, that will return a very big value, and so on.
Okay, so that's all we have. That's kind of the basics of a table view. Does anybody have, before we move on, do we have any questions about how to play with table views and controllers?
What are you supposed to do if you have like a megabyte of data that you want to load into your table view before your app starts? Like, how do you? What's the best way to put it in there?
So you're as a delegate, you're going to be called every time that it needs to populate one of the cells, whether it's one that's being scrolled in or scrolling out. Mm-hmm. So you're able to dynamically do that. You'll know which row that it's asking for. So you can stream things as you want, and you can stream and cache things and be as clever or as dumb as you want about it. It's best if the only time that's going to be a limitation is if you're on an iOS device. So I'm pretty sure that Apple recommends that you not have a megabyte worth of table data at one time. You should have some way to cache things. Like if you got like a bunch of images, having cached thumbnails is the way to do it, and then loading the image when as necessary. So loading on demand, loading on the fly. But as the delegate, you'll get called every single time a row needs to be refreshed, and you'll know exactly which row it's talking, which row that it wants, and which column it's going to want. So you can be really, really tricky with it.
So if you have a really large data set, it's common for you to not really initialize anything in the beginning, and then only start looking for data when the table view asks for data, and then you make some web request or whatever it is you have to do to actually get your data. But only you will defer those until that cell needs to be loaded. Okay, any other questions about table views? You'll get a really good example of hands-on working with a table view in today's lab. You'll be writing your own version of the Notes app. So it'll give you some real good practice of working with a table view.
All right. I'll let Kevin jump in and talk about the bonus lectures.
Okay, so we're kind of winding down in our coverage of what we consider to be the core essentials of what you need to do to write Mac and iOS applications. And so I think we have one more week of lectures where I'm going to talk about user defaults and saving state, and then Gwen is going to talk about performance. And then after that, we are basically going to talk about all kinds of cool frameworks and APIs that you guys probably are going to want to be able to use in your projects. And these are some examples of ones that we think are really common and lots of people like to use. We're going to put up a Google survey of kind of just asking you guys for interest so that we can prioritize these based on who wants to see these the most. And if you have other ones that you're interested in, you can make a request, and depending on how much time we have, we'll be able to prepare a lecture for that. So I just wanted to give a brief overview of some of these core ones that we like to talk about. And so the first is core animation, which is this really powerful framework. Obviously, it can handle animation, but it's more general than that. It allows you to do really sophisticated graphics processing, layering, projecting, really clever compositing effects. And it's got this neat layer abstraction that very much mirrors the idea of views and having layers and sublayers and that kind of thing. And this is really powerful framework. So you can see this is an example image that's generated from Core Graphics. So you can see there is this background image, and then it's overlaid with this Apple logo, and there's some clipping going on, and there's some vignetting, and there's all kinds of composition going on here. So there's a lot of really sophisticated things that you can do with core animation. And what's cool is in addition to being able to just do all this cool graphics, you can actually animate all this really cool graphics really efficiently. Now, Core Audio is a massive, massive, massive framework for any audio question you've ever had or anything you want to do with audio in your application. There's probably a tool for it in Core Audio. It's a massive, massive, massive framework. So it can do things like recording, editing, playing back, compressing, decompressing, handling MIDI, doing even low-level signal processing for audio for doing audio type stuff. Really, really big, really powerful framework if you want to work with audio. Core Data is Apple's their alternative to a traditional relational database. It's this really cool modeling tool, and it allows you to manage arbitrarily complicated graphs of objects. And it gives you a lot of really cool behavior, like it can handle it. You basically get undo and redo for free because it's able to track changes to this massive object graph, and it can write it out to a file and keep it in a backing store on your hard disk. Really, really, again, this is a really massive framework, but really, really powerful, and it's really great if you have a large data set that you want to work with. Core Location, as you can guess, is an API that's available on iOS for accessing the location of the users of the device, and if the device has a compass, it can also determine what direction it's facing. So really cool API for handling, and this kind of will tie together with working with MapKit, which is a framework for actually displaying maps in your application. Core Motion is a framework for handling accelerometer events, gyroscope events, and also, I believe, compass events to kind of really be able to very precisely, depending on the hardware, determine the orientation and speed and acceleration of your device. So if you want to have some application where you're driving and you want to tilt to kind of figure out how much you're turning, Core Motion is a framework to allow you to hook into the accelerometer to figure out how much you're turning. Grand Central Dispatch is a parallel processing framework that's been available since Snow Leopard. And it's a really cool framework for doing parallel processing because it abstracts away a lot of the hard stuff when you're writing. So if you've ever written a parallel program, there's a lot of overhead in generating the threads and then spawning off the threads and joining the threads and actually managing the fairly low-level, not very interesting details of writing a multi-threaded program.
Any CS162 alumni here?
Yeah. So Grand Central Dispatch is this really cool, very high-level framework that you just basically provide blocks of code and you stick them into queues, and then GCD fires off the queues whenever it has time for them. It's this really interesting task-based model of how to do parallel processing where it really lets you focus on the things you want to get done, and then GCD schedules them and very intelligently schedules all the different threads and manages the threads. So it's this really very cool parallel processing framework. I mentioned MapKit. It's a framework for displaying maps
and being able to annotate and draw pins on the maps, and it handles things like zooming and panning. Very cool framework. But that probably will go together with a lecture on core location because they're very tightly related. Message UI is a very, very simple framework that basically allows you to embed MMS, or maybe not MMS and SMS messages and email messages within your application. So that way, if you want to be able to submit an email right within your application, the user doesn't have to leave the application, go to mail, write a mail, and then send it out. You can actually send mail and messages right from your application. WebKit, if you want to use WebKit, it's a framework for drawing loading web pages in your application, and it's very powerful. Glenn did a demo last semester where he wrote a browser in like 5 minutes because it does almost everything for you, and you just add a few things around it, and it just things like forward and backward all work basically for free with WebKit. It's a really cool framework if you want to display web pages in your application. And if you guys have any others that you want to see, like I said, I'll be putting out a Google form sometime in the next few days. That way you guys can pick your favorites, and we can determine what order makes the most sense based on who wants to see them. And then
we did iCloud last semester too.
that hasn't been added.
So the iCloud is also a possibility.
Yeah.
Much more condensed.
Okay. So there were 5 of you that asked for iPods. I have 5 iPods today. So if you're one of those people that asked for an iPod, come see me.